So just before we actually get going, just to make this real, what you're seeing on the screen right now are the however many students taking discussions that are working on the platform that I'm about to tell you about. And here are the 360-odd students that are enrolled this semester using the platform that we're about to talk about. So we're a little ahead, but we should get going, right? Fantastic. Should I get the music actually? Fantastic. Okay, so it's our pleasure to be able to tell you a little bit about this project, which we call the Open Education Project. And in some sense for me, it was kind of eye-opening to see what could grow out of having this collaboratory with Red Hat here at BU. And I'm not wearing my hat as a scientist today, I'm wearing my hat as a teacher. Because in the end, the idea of keeping our education about systems, fundamentals about how the computing world works, seems radically important that it's open to me. And what we were able to do was by having people who are passionate about systems education and people who are passionate about building technologies out of open platforms together with a commitment that the things that we build remain in the open source and open access to what we're building. On a more pedantic level, the project's goal is to enable both an environment and platform so that educators can create, publish, and operationalize high-quality, open-source material, meaning we don't want anybody being able to stop us from giving it away for free. So, sorry, yes, as in free beer. And that a student only require a web browser to be able to access our materials. Now, we've been very fortunate to have brought together already a fledgling community of many folks. So the work that Danny and I are going to present is really of a much broader community that is already formed. But I would like to really say thank you to both Hugh and Heidi, who have had real faith and commitment and support for this, because this is not your typical thing of getting researchers and your industrial scientists together. So in the next couple of slides, I just want to give you a quick sense of the kind of things we're trying to achieve in our systems courses. And specifically, I'm going to use my course as an example, just so you have a sense of both the things we're trying to achieve and the challenges and the opportunities that exist. So in my class, we are trying to get people to understand some very theoretically important but foundational ideas, right? Like, what is a binary architecture? What is an OS kernel? What is a file? What is a process? What is an executable? How does all this crap run at the bottom as a binary representation? What's a tool chain? Things that we older folks take for granted that everyone surely knows. These days, with iPads and smartwatches and programming in IDEs where Java and Python are your languages, folks don't have a solid grasp of even what a file is. On the other hand, we are committed that what we teach is not just theoretically nice ideas, but the skills that they get out of the class will enable them with our future classes. So I need them to know what a terminal emulator actually is, what the core Unix commands are and how you become productive, how to use, God forbid, an ASCII editor. What is Git, not GitHub? How does assembly code actually work? And lo and behold, you can actually write it. And you can debug it. What a linker is. How do you go along a tool chain with something like GCC? And that GCC is an exemplar. And for us, one thing that we really want to drive home is understanding how to debug at the binary level is a skill that you will hold on to for the rest of your life. Turns out, also, there's some utility in learning how to read manuals. Now, this is a broad ask. We have a lot of ground to cover, so I don't expect anyone to read all of this. But, you know, we have to cover things from our goddesses like Admiral Grace Hopper, teaching us that, look, you don't have to write assembly code. Compilation, translation is a real thing. 2, what is an address space layout? 2, being able to actually debug in a terminal with GDB. How to use Git properly, and even how to read Intel manuals. Now, there's a lot of challenges because the class I'm teaching has an enrollment of 300 people. Okay? 300 people with a radically diverse background. So that's a challenge. You have to be able to scale this experience, or you do it lip service and you don't teach anyone anything. You just give them their A's, they go home, we make money, we're all good. Now the other problem is, everything is behind a paywall these days. So much for all our cloud and open source access and operating systems. The publishers hold the keys to the kingdom. Even though I, as a professor, want to develop solid material and give it away because I believe that an education on how things work is fundamental, lest the world become magic. So what we managed to do is pull together a platform out of open source where we hijack a data science platform and turn it into, lo and behold, Back to the Future, a 1970s terminal environment, web accessible. But that same environment is usable for accessing and authoring information. So in my 2 minutes past my time slot, I'm going to show just 3 quick clips of videos. So there are 3 fundamental environments that we built. One is that through a web browser, my students can access an environment where when you click on it, all you're allowed to do is open a terminal. And in that terminal, we've curated all the software necessary, I'm sure you can't read this, but to write and assemble C and assembly code and debug it, use Valgrind, look for all kinds of things that are lurking below the surface. This same environment is what we use in class to use non-PowerPoint, non-Google slides that are open source, in which we can do our presentations and at the same time we can open exactly the same terminal. Okay, well, I'm not going to try to fight with this right now, but you can watch it at the poster. You'll see us pull up a terminal environment and I'll open up a terminal environment in class with those slides showing. Finally, we also have the exact same environment for authoring high-quality textbook material that we can then publish on the web, giving folks access. And again, these textbooks contain live man pages. They contain actual terminal output and sessions. So it's real. I'm not making things up. Okay. With that being said, I'll hand it over to Danni, who's also part of the fact that it also takes real technical skills to make all of this come together. I don't know if you want that or not. Oh, sorry. Yeah.
Hello everyone, my name is Danni. I am a senior software engineer at Red Hat. As we've already seen from Dr. Appavoo's demonstration, OPE project provides a powerful platform for interactive and engaging educational content. So as a software engineer, my focus is on the actual development work that underpins this project. Firstly, our engineering objective is develop tooling and demonstrative systems that facilitate the ability to use and extend the open education project and test framework. Now, let's take a closer look at our timelines and milestones. In 2022, we developed features for user-friendly Jupyter book content creation. We standardized container image building process and initiate a comprehensive testing framework. In the spring of 2023, we are now focused on an OPE command line tool, a pre-allocation tool, and minimizing image size, as well as improving testing coverage. For our upcoming short-term goals, firstly, we are now in the process of setting up a testing cluster with self-managed roles on NERC environment, which allows us to thoroughly test and run open education project. And secondly, we will enhance our testing framework to make sure that its usable and run and test processes are reliable. And additionally, we will continue to develop OPE image in a Fedora build. As a thumb test, in the daily build of Fedora, Jupyter Lab and Jupyter Notebook, a modified version of Jupyter Notebooks are now available. With all of this development work, we are optimistic about the possibility of adding an OPE version in a future Fedora build, once we finish all the necessary work. I want to highlight the significant contributions made by our brilliant interns. In 2022, Abrami Yellen standardized the image building process and developed both Fedora and Ubuntu-based multi-stage image build. Xinyi Wu created OPE CI/CD GitHub action workflow, and she also created an OPE textbook template. She initiated a roles testing framework for roles. And for Yiqing Zhang, she integrated RISE extension as well as developed a new slides layout extension in Jupyter Lab environment. And in 2023, Griffin Herring is now adding permission tests to GitHub action workflow to expand the testing coverage. Isaiah Stepton is improving container image building process and minimizing image sizes. Keely is working on shortening the wait time for roles instances spawning process. He is also working on an OPE command line tool to integrate OPE features. And Eric Monson is helping Dr. Brager to create interactive textbook content for OpenOS class. Arlo is directly engaging with CS Tutor course content and identifying prioritized tasks features based on the class feedback. We are excited to see these valuable contributions that the interns have made and will continue to make. So I want to show you a diagram created by our intern Xinyi Wu. Although you cannot see the diagram very clearly, you're welcome to check back later on this slide. So this diagram provides us an overview of the current OPE active repos and branches and the OpenShift clusters that we are running, as well as the source-to-image building pipelines. With this diagram, we can better understand the relationship of different components and how they are working together to support our OPE goals. Here are some references you could take a look to know more about open education. So this includes our OPE-based repositories, Dr. Appavoo's and Dr. Brager's interactive textbooks, and 2 Red Hat talks. We encourage you to explore these resources for further information about Open Education project. Thank you for your attention. We welcome contributions from everyone. We hope you found this presentation interesting and informative. If you have any questions or feedbacks, please feel free to contact us. You will also find us during tomorrow's poster session. Thank you again.